What are the major global sources of black carbon, and are there any important regional differences among these major sources?
Okay, so and we know black carbon is a particle produced during the incomplete combustion of biomass and fossil fuels. And during that combustion, there are not only these particles, but other gases that are produced and some organic carbon as well. So it is a mixture, and it is never emitted by itself. And it is important both in terms of its impact as an air pollutant and, of course, as a climate forcer. So the lifetime of black carbon in the atmosphere is on the order of only a few days. That means that its ambient concentration, it's not homogeneous in the atmosphere, and will depend on the proximity to the different sources of black carbon. So, so the sources are varied and will depend on the anthropogenic activities. Globally, we can talk about emissions in terms of broad sectors, like, say, for example, transportation and certain industrial sources, which mostly rely on fossil fuel combustion. But the studies indicate that most of the emissions globally are associated with the residential use of biofuels for heating and for cooking. And in particular, I'd like to mention that this source is it's more prevalent in developing countries, and the vulnerable population is exposed primarily to this toxic pollutant. The artisanal brick production industry is small globally, but it can contribute locally to very large emissions. And those emissions truly affect the already vulnerable populations. So mitigation measures to control those emissions should involve the communities that whose livelihoods depend on those brick kilns that contributed to large emissions and deteriorate significantly their health. So it's important to distinguish that that this pollutant has quite significant inhomogeneities around the world, and it's difficult to talk about global concentration because of its lifetime.
So how have global black carbon emissions changed since 2011, when the first UNEP WMO report, Integrated Assessment on Black Carbon Tropospheric Ozone, came out? And how are emissions expected to change going into the future, particularly towards 2030?
Some of the emissions have decreased, especially in North America and Europe. But there have been really very modest decreases in, say, for example, East Asia. And on the contrary, Africa has experienced a very large increase, almost 20%, and Latin America and Central and Southeastern Asia also have showed emissions. So as we know, the sources are different in different regions, and the efforts to mitigate those sources have also been different. And there has been more effort in certain regions, more developed, that include more developed countries than others, where the developing world is still continuing emissions. In several megacities around the world, there have been measures implemented to reduce emissions of black carbon and several of the other co-pollutants. And that is because of the immediacy of those pollutants in terms of risks to the health of the population. So in some regions, the megacity, the authorities have been leading the efforts to reduce black carbon and have achieved some success because of that.
How has our scientific understanding of black carbon's impact on the climate changed since 2011, and what are the implications for the Climate and Clean Air Coalition?
Well, I'd say that since 2011, our understanding has improved, and that's made some things clearer. And unfortunately, it's made it clear that some things are even more complicated than we thought. So overall, I think we are continually learning more about the complexity of black carbon and its co-emissions and how they react with one another, and the mixing state of the aerosols change, how they are oxidized and their optical properties change. And so we have, I would say, probably no more confidence, maybe even less confidence, that our models are capturing the reality of the complex physical world. That said, what we're seeing is generally models are showing a weaker impact on global mean climate from black carbon and its co-emissions, but they are showing in some cases very much stronger regional effects, and that's particularly true where loadings are so high over developing Asian countries. So the South Asian monsoon, for example, seems to be extremely sensitive to black carbon, and it's far more sensitive than it is to equivalent forcing from CO2. I think the implications are that even if we have evidence that black carbon is playing a small, though not negligible, role in global mean climate change, it can be extremely important for regions that take action to reduce it based on decreasing the disruption to regional rainfall.
What are black carbon's main co-emitted pollutants, and how do they impact air quality and climate change?
The main co-emitted pollutants are a mixture of both gases and aerosols. The gases lead to ozone production, and the aerosols lead to increases in PM 2.5. Both of those have damaging effects on air quality. The climate impact is clearly positive in the sense of causing more warming from ozone, black carbon, and brown carbon. And it is cooling from some of the other co-emittents, the organic carbon, meaning the net is very much source dependent. That's something I talked about previously with climate, but what's new about the air quality is that since all of the effects are damaging from an air quality point of view, the sum of these is extremely clear that these are very harmful to human health. And updated epidemiology indicates that while in the past we'd focused on a few identified health outcomes, that we have been missing a very large portion of the total burden of disease associated with particulate matter exposure. And what this shows is that if we went back and looked at results from calculations done 5 or more years ago, we are almost certainly dramatically underestimating the total health benefits of reducing black carbon and its co-emissions on public health. The calculations that we did years ago that found 2.4 million lives could be saved each year are therefore extremely conservative. With the new understanding of the impacts of ambient air pollution leading to more than double the impacts, along with the fact that we didn't include indoor air pollution back when we calculated those numbers, the actual public health benefits that would come from action would certainly be greatly larger than the numbers we provided years ago.
How does technically achievable black carbon mitigation relate to decarbonization efforts consistent with 1.5 degrees Celsius levels of mitigation ambition, particularly in the 2030 timeframe?
Black carbon, a nice thing about black carbon is that a great deal of it, the vast majority, is potentially abatable via technical controls. And this separates it from some of the other pollutants that can sometimes be more difficult to control via solely technical measures. If we wanted to achieve the dramatic decreases in emissions that are consistent with 1.5 degree pathways, we could do so by putting in place technical abatement controls. And these could get us all the way down to those kind of levels, except that we would have to put into place virtually all abatement measures and put them into place virtually everywhere in the world. Now, most of those abatement measures are associated with the decarbonization that takes place under 1.5 degree scenarios, and that gets rid of emissions from motor vehicles, industry, etc. It leaves behind the large residential source, and of course, decarbonization is not directly related to things like agricultural waste burning and small industry like bricks. So there are additional efforts that need to be made to really target those sectors that are not directly related to fossil fuel combustion, which is to say really most everything outside of motor vehicles and large industry. Much of that is related to providing energy access to the poorest and to small industries that currently use inefficient combustion as part of making their product. And so those things are not related directly to decarbonization, but if done intelligently, can be complementary to decarbonization, namely by bringing access to renewable energy rather than fossil energy to the world's poorest people who currently burn biofuels and emit large portions of BC.
Are there any links between air quality and climate policies that can drive increased ambition towards 2030?
Yes, there are links between these policies, and in fact, there's such a strong realization, which I think is continually growing stronger, that public health is of paramount importance to people. It can be changed in the near term, and this has led to many jurisdictions setting very strong near-term air quality targets. In fact, they're so strong that they cannot be met with traditional end-of-pipe measures alone. And so what we're seeing is that to meet these air quality goals, you have to decarbonize, because that's the only way to really remove all of the sources of the traditional criteria pollutants. And so in this sense, these strong air quality policies are driving decarbonization, and decarbonization comes about really as a co-benefit of air quality policy.
Based on your experience in the SNAP initiative, can you explain how and why countries are incorporating black carbon strategies into their decision-making process?
So the interest that countries have in black carbon strategies is that it's something that they can complement the existing CO2 and other climate change strategies that they have, but also the link to their air quality strategies is really appealing to these countries. Sometimes these local air quality issues are of much greater political importance than the often small contribution that some countries make to global climate change. And it's easier for them to get interest from their policymakers by emphasizing the fact that these measures will give local benefits in terms of improved air quality and in terms of improved health, and at the same time will help with the climate agenda. So many countries have wanted to add black carbon to their portfolio of climate strategies, but at the same time use it as a way of highlighting and improving their air quality and highlighting those strategies that will get them to better air, cleaner air. So if we look at some of the countries who have incorporated black carbon into their strategies, for example, in Ghana, they had their original strategies to include their NDCs, and then they've complemented those with strategies which address black carbon. And then looking at the benefits in terms of both the climate benefit as well as the air quality benefit. Another interesting example is the work we're doing with Costa Rica, where they have already decided to decarbonize their economy. And then they want to complement that with black carbon measures as well to make sure that they reduce further their impact on climate change and at the same time improve their air quality.